Hi, so continuing our discussion for the homework 5, question 4, determine the mesh currents IT in figure 14.59 if the current through the 1 millihenry inductor is 1 at time 0. Uh, let's start by defining two nodes, V1 and V2. So the voltage let's like the voltages in time domain at V1. So V1T equals 6 cosine 2T minus 13 UT volt. So let's quickly check the conversion function for this cosine. Uh, wait, all right, let's right, let's paste this part here. So cosine omega t minus theta is the last one here. So this is the equivalent output. So we can say that V1S equals S cosine theta, which is 13, minus omega, which is 2, minus 2 sine theta, which is 13, over S squared plus 4. Similarly, V2 is 6 cosine 2t ut equal 6 cosine 2t. So 6 cosine, is it 6 cosine ut, 2t u of t? Since both of them are on the same frequency, we can solve directly without using superposition. This is important to note as well. So cosine 2t is this example. So getting the Laplace transformation will give us V2 of S equals S over S squared plus omega equals plus over omega squared equal S over S squared plus 4. So that's our first step. Then let's start by um, or start by drawing the circuit and assigning the two nodes. Let's draw the circuit in its equivalent S domain. Or before that, we can start by getting the initial conditions. So the initial condition for the current is 1 ampere. And from this table, we mentioned that if we have a current source, it's converted to a current source in S domain with a voltage source with the following value, negative L I node 0. Or so taking this into consideration, let's convert the circuit into S domain. We can copy it as well. So I mean, you can skip this part if you want. So we forgot something here. Forgot it. There's 6. And for this example, we forgot that there is 6 as well. 1, 2, 3, 1 milli S for this inductor, and it's 1, 2, 1 milli, 5 milli, the I1. Let's here. This is I2, I4, and there is a voltage source we shouldn't forget. Negative positive with a 1 millivolt for this capacitor, 1 over CS, which is 1000, 1 over 1000 micro is 1000 over S, 6S over S squared plus 4. Solving for cosine 13 and sine 13, I think it will be 5.8 S plus 2.7 over S squared plus 4. And this capacitor is 30133. It's 750, 1 over 750. 3, 3 over S, and that final resistor, it has an impedance of 2, or resistance of 2 impedances. So let's apply KCL at all the loops. KCL at loop 1, we get something like, um, which one is, this is loop 1. We get negative VS1 plus, let's call this C1, C2, L1. I hope hopefully this will make things easier. And we can substitute in the end with MATLAB so to reduce the mistakes. So negative VS plus, or let's just try the values. 30 on 3. 1, 1, 1 over C1S times I1 minus I2 plus 2 times I1 minus I3 equals 0. All right. KCL at loop 2, we get 1 over C1S times I1 times I2 minus I1 plus, so 5M I1 plus 1M, so 1M S times I2 minus I4 minus 0.001, which is the voltage here, 0.001 equals 0. So we continue the same thing for the other two loops. Let's just do it in MATLAB. It should be easier. Mm. So let's start by defining a symptom. S, so S, I1, I2, I3, I4, loop 1 equal V1. Right, let's define as well V1 SYMS V1 C1. So uh, V it's negative V1 negative V V1 plus 1 over C1 S times I1. Let's change that to I1 minus I2 plus 2 times I1 uh 2 is the resistance. Let's call this resistance R1 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 I1 minus I3 I1 minus I and 2 3 equals 0. So let's change the values. I subscript 1, I subscript 2, I subscript 3, I subscript 4. Let me pause and write the equations. So using MATLAB, we can write the four loops, and then you can display the loops. If you are satisfied with the output, you can plug in the values for C, V, uh, C1 and C2, and V dependent. You can plug in all the values, and you can use functions like solve. You, you can give it the four loops and the four unknown values, I1, I2, I3, I4, and you will get the values. You'll get it automatically solved.